Chapter 4, Mechanisms, Part 2 of 2. Calculating gear ratios in gear trains. The mechanical advantage of a gear train is identified by its gear ratio. The process of calculating the gear ratio of any gear train begins by counting the number of teeth that exist on each gear. GR, or gear ratio, equals the number of teeth on the output gear divided by the number of teeth on the input gear. Calculating the gear ratio of an entire gear train is done by multiplying the mating gear ratios of each pair. The gear ratio can be calculated by multiplying the gear ratio between gears A and B times the gear ratio between gears B and C times the gear ratio of gears C and D. This formula only works for a simple gear train. Steps for finding the gear ratio. Step 1. Identify the number of teeth that exist on each gear. Step 2. Identify the sets of mating gears along the gear train. Step 3. Calculate the gear ratio for each set of mating gears along the gear train. Step 4. Multiply the gear ratios for each set of mating gears along the gear train. Gears. If the relationship between the driving and driven gears is all that matters, why design a compound gear train? Why not make gear trains simpler by using only 2 gears and get rid of idler gears altogether? Moving from a compound gear train to only 2 gears, one gear would have to be much larger. Speed and torque ratios. One of the major advantages to using gear trains is the ability of the designer to manipulate rotational speed. Rotational speed, how fast an object rotates around an axis. Speed ratio, or SR, is the ratio between the rotational speed of the input gear and the output gear in a gear train. Another major advantage to using gear trains is the ability to manipulate torque. Torque is the rotational equivalent of force. Torque is measured using the Greek letter ta, and is the tendency of a force to rotate around a body on which it acts around an axis. The torque value is the product of the radial arm distance, r, and the magnitude of the perpendicular force, F, with a little perpendicular line drawn there. Torque is measured in Newton meters. The formula for torque is torque equals the radial arm distance times the perpendicular force. And there's, again, our little perpendicular line drawn there. Speed and torque ratios. Torque ratio is calculated by dividing the input torque by the output torque. Torque ratio, and there's our ta, the input value for our torque, and our output value for our torque. Sprockets and chain drives. Though they are less accurate and not as compact as gear systems, power chain mechanisms do have the advantage of being easily assembled. Chain mechanisms are used to change rotary motion in linear motion. A sprocket is a toothed wheel that is used in conjunction with a continuous chain to transfer rotational speed and torque from an input shaft to an output shaft. An example would be a bicycle chain. Though they are similar to gears, sprockets are not designed to mesh together. A chain is a series of links that are uniform length and fitted together to form a continuous band. Of the various types of chains that are used, the most common is the roller chain. Roller chains consist of 2 repeating components, the pin link and the roller link. The center distance between sprockets is important, although there is more room for error in this kind of drive system in comparison to geared mechanisms. The sprocket center distance is a function of the chain pitch, which is the distance between centers on one chain link. Chains that have large pitch values are able to handle greater load capacities. Designing roller chain drive systems. Sprockets that are joined by a chain will spin in the same direction. An adjustable idler sprocket may also be used to return a loose chain to its proper tension. One side of the loose chain is expected to sag slightly during the operation. Answer the following questions in your engineering notebook. How does a mechanism differ from a simple machine? What are the applications of a linkage system? What kinds of products contain a cam and follower? What are the applications of gears? How do you calculate the gear ratio, speed ratio, and torque ratio of a simple and compound gear train? What factors must be considered when an engineer designs a chain drive mechanism? And identify 5 different types of mechanisms and identify one application of each.